Hello, I'm Louise Leenen and I'm an Associate Professor in the Computer Science Department at UWC. And today I want to talk about a very exciting topic, artificial intelligence. You probably hear about AI and read about AI every day in every media outlet. But let's look today a little bit about what it actually is. And at the second half of this short talk, we'll actually address how you can start learning more about AI by enrolling for a BSc degree at the University of the Western Cape. So let's start. You'll find that there are lots of definitions given for what artificial intelligence is, and the reason for this is that it's a very broad field. So I start off by looking at what a few people have used as definitions for AI. So the first reference to AI started very early on, even before 1956, but John McCarthy, a very well-known scientist, actually coined the term. And he referred to artificial intelligence as the science and engineering of making intelligent machines. And we'll talk about intelligence a little bit later in terms of machines. And then we have a few other people refer to the automation of intelligent behavior or creating machines that perform functions that require intelligence when performed by people. All of these are valid definitions of AI. But what is important for us to understand is that AI is a very broad discipline. And this image here just shows you a few of the branches of AI. Now, let's look first at machine learning. This is the branch that you'll read probably the most about in the media and in papers and so on. And here, often people referencing to applications of machine learning. Then we also hear a lot about computer vision, self-driving cars need cameras to actually get input from this environment, the road that they're driving. They need to see the pedestrians and so on. So computer vision has many applications in real life. It's part of the broader field of artificial intelligence. And then there are things such as data mining. You've got large volumes of data available, which is referred to as big data. And we have to find means to process this data and make meaningful conclusions or know what the data is about. And then we've also seen, all of us have seen applications of natural language processing. If you think about Siri or Alexa, those are types of applications that are commonly used today. And then we look at the top. You probably won't read or hear in the common media about knowledge representation. This is a branch of AI that's really important because we need to be able to present data or represent data in a way that machines, so that is a laptop or your iPhone or other phones, any device, can understand data. So data representation is very important. But let's jump in and start looking at machine learning. Now, if you look on the left-hand side, traditional programming, where apps are written and so on, you actually have to describe, the programmer has to describe in the code certain characteristics. If we want to look at descriptions of whether of cats or dogs, we have to describe in traditional programming that a cat has a tail, it has pointy ears, the type of sound it makes, and how it differs from a dog. Dogs also have tails and snouts, but they make different sounds. In machine learning, we follow a completely different approach. Imagine you have lots of photos or drawings of either cats or dogs or other animals or humans, and you want an application to tell you whether a new picture it hasn't seen before is a cat or a dog or neither. So what we do is we take our data, the stacks of pictures of cats, dogs, or other objects or people or other animals, and the data is labeled. So what we say, for each picture we add some information, which is often referred to as a tag. If it's a picture or drawing of a dog, it will have the tag dog associated with that picture. So I pointed to the cat, I mean the dog. And similarly for pictures of cats, the tag will say cat. And if it's not a dog or a cat, the label or the tag will be different. It will be human or car or whatever the picture is. Then we feed that into our machine learning application, and it learns from the tagged data. So when it's represented or presented with a new photo, let's say there's a photo of a new puppy, newly born puppy, then that application has learned what features a dog has, and then it will specify, yes, this is a dog. Or if it's being presented with a photo of something else, then it would have the ability to classify it as not being a cat and not being a dog. So that's a very short general description of machine learning, but I hope this gives you a little bit more of an idea of what machine learning is. It learns from sets of data. Now, the other branches of AI are also used in many applications we use every day, and I'll talk a little bit about that later. Sorry, I've misspelled IBM there, but IBM's Watson, it's a very large system that was built over a number of years, and it's constantly being improved. And Watson has a number of very advanced capabilities, and it uses a lot of the different branches of AI, for instance, natural language processing, knowledge representation, and ontologies. You'll see if you Google IBM's Watson that it's being applied in the financial world, for health applications, many applications. But one of the exciting things that Watson managed to do even as early on as 2011 is compete against two humans in a US a program. It's actually a competition called Jeopardy. And there you'll see in the middle is Watson. And Watson beat both the human opponents. These were the two champions at that stage. And Watson could actually beat them. So if we go back to the previous slide, you'll see that Watson is an open domain question answering system. So in this game, Jeopardy, the host gives the answer to some question, and the participants must actually phrase what the question is. And in this case, Watson was much better than the humans. He beat both the champions at that stage in the machine. So other instances of exciting AI applications that you've probably come across is the fact that humans now were able to develop games that play chess or Go. In this case, it shows an application of Go, and it actually beat world masters. Then we all have seen applications of GPSs, intelligent navigation systems, and I've referred to self-driving cars before. Now, if we look at GPSs, we actually need what is referred to as AI algorithms that underlies these applications. They search in intelligent ways for all the possible routes between a given start position and a goal state. So you type in what picks up your current address, and you type in where you want to go, and your application search intelligently for the fastest route, taking into account things such as the current traffic or road closures. And when we look at self-driving cars, we also need these type of navigation applications, but it needs a whole bunch of other things. As we've referred before, it needs to be able to see what's going on in its environment. It needs to see the road, the red lights, pedestrians, possibly an accident that it has to pass on the road with obstacles in its way. So it's a very advanced form of AI applications. Other applications that AI systems perform better than humans is lip reading and also transcribing. But it's not all good news. There are also some concerns when we build AI applications. And many well-known scientists have expressed their fears. And these fears usually relate to things such as automated weapon systems. And this is where you have a weapon system that once the human or the soldier actually engages this weapon system, it is then automatically behaving on its own. So you have a missile that may actually be locked into a target, and when it is autonomous, it means the human cannot interfere to stop the activity this missile has been instructed to do. And one can easily see why this would cause concerns among communities, all communities. So you'll see that both Stephen Hawking, Bill Gates, and Elon Musk have at various times addressed their concerns about the development of AI systems. So we need regulations to make sure we build ethical systems, that individuals' privacy and other rights are protected. And then there are also concerns about job losses. Now, I believe that some jobs will be replaced by other jobs in the AI world. So we don't have the ability yet to develop what is referred to as conscious AI. In other words, create human-like robots. We can, and they are very well-developed robots, but they don't have a conscience like humans do. And it's very unlikely that we will be able to build fully functioning robots that has a conscience. I don't believe it will happen, at least not anytime soon. But there is the fear about AI systems replacing existing jobs. As we've seen before, AI systems can do lip reading, transcribing, but it's not all bad news. These jobs will or may be taken over by AI systems, but new jobs will be created because we still need humans to develop these systems. And this is where hopefully you will come in and you will learn more about AI and become trained in AI functionalities and skills. And now the rest of my talk will look at how you can become competent in producing AI practitioner of some sort. So where does that start? It starts by studying computer science. And I'll first tell you a little bit more about computer science. So AI can be seen as one topic that is covered in a computer science degree course. So you need to understand what the rest of the course will involve. So it involves the understanding and design of computers and more about computer programs, and that would be the computational processes. So if you look at it in its most basic description, computer science is concerned with the understanding of data or information and how to transfer that information and also transform the information so it becomes usable. So we focus a lot on making processes efficient and using some form of intelligence, and that intelligence is writing clever algorithms. So an algorithm is the basic steps in which we program a computer to do what we want it to do. So a large part of your studies will involve the development of algorithms. We teach you how to develop, design algorithms, and then to implement them, in other words, to code them in some computer language. The applications of computer science is often referred to as IT, information technology. But there's also information systems, which is a different subject that you can also take at UWC or any other university. And these two disciplines work together, computer science and information systems. So information systems has more to do with the development of business applications. So let's look a little bit closer at the computer science program at UWC. So our program is aligned with international standards and also South African standards, which is approved by SAPA. You can either opt for a 4-year program, that's the extended program, or the 3-year program. And the details here are shown of what you're required to enroll for if you take the 4-year program or the 3-year program. Now, with the 4-year program, you'll see in your first year and your second year what your options are. So you have to take mathematics, physics, and introduction to science, and then you'll move on to more advanced mathematics. And in your second year, you'll do computer science, the first computer science subject. And then there are also a number of other subjects you need to take, because when you enroll for a BSc, you have to take a combination of different scientific subjects, of which computer science is one subject and mathematics is another one. So in your first year, a theory will be introduction to computer concepts, and these few bullet points actually cover what you will be learning. And you'll also learn very basic skills such as word processing, the Windows operating systems, and databases, etc. And then in your first year, so if you take the extended program, this will be the second year of study, but for the 3-year program, this will be your first year of study. You'll spend a lot of time developing problem-solving skills, designing algorithms, and then implementing the algorithms. First in Python, that's a programming language, and then in Java, in your second semester. Then in the second year of computer science study, you'll do algorithms and data structures, and algorithms, and it's actually algorithm complexity and architecture. Now this is a very important year of study, because these algorithms are the basic algorithms that will lead to AI algorithms. We talked a lot about intelligence. You can write simple steps for a program to follow, but when we deal with complex problems, we actually need to make sure that we design very intelligent algorithms. As the algorithms I talked about earlier, that is the basis of GPS, where it has to do search for all the possible roads. These data sets become very large. In other words, the search space for finding the best route you can take will take a lot of time if it's not done in a clever way. So what I'm saying is you learn the basics or the core techniques for developing algorithms in your second year, and then in your third and fourth year, we move more into the artificial intelligence area, where we look at intelligent algorithms. But this is the core or the basis of getting to understanding AI in general. So in the third year level, you'll do machine learning. And that is really your first AI course that you will take. You'll also learn other things, operating systems and computer networks, that are also important, as well as software engineering and human-computer interaction and databases. But the machine learning component is important if you have an interest in artificial intelligence. And then obviously you have to take other science subjects as well, maths or physics or stats or information systems. And then when we get to the honors program, after 3 years, you will graduate the BSc program, or if you've taken the 4-year program, then you'll have a BSc degree. And then we strongly urge you to enroll for an honors program. That is a 1-year study for full-time students and 2-year study period for part-time students. And a full 4-year degree up to and including honors is an international standard. So it's really a good idea to enroll for the honors program as well. And this is where you'll really get the opportunity to do a lot of AI courses. There's an introduction to artificial intelligence course. And then we also have internet programming, Internet of Things, cybersecurity, cloud computing. All of these have aspects of AI in them. And then we also do research. When you finish with your honours degree, then you enter into a master's degree and PhD. So both, rather all three of these degrees, the honours, the master's and the PhD, involve research that you have to do on your own. And if we go on, you'll see that our department has a new focus on the fourth industrial revolution. So we include a lot of research opportunities in Internet of Things, virtual reality, artificial intelligence, big data engineering, etc. Our department students also compete in various challenges and competitions every year, and they have really performed exceptionally well over the past few years. Last year they came second in the National Sunrain Cybersecurity Challenge, and these are our students. There you see them. And they also scored a second place in a high-performance computing competition. And lastly, but not the least important, we really place an emphasis on attracting female students. So we do have specific societies to engage with young female students and to make sure that they don't drop out of computing. And we at all times invite all male students to also become part of the Women in Computer Studies group. They often invite female computer scientists and other female scientists to address the students. I want to thank you for your time, and I hope this short talk will answer some of the questions you may have and also develop some interest in the exciting field of artificial intelligence. And I hope to see you next year.